Aloha, everyone, and welcome
Oh.
to day 12 of the OpenAI 12 Days of OpenAI. I'm Jyunmi, and I am joined by Karl today, but we'll see if anybody else
What's up?
joins up. It'll be interesting. Oh, it looks like we got Andy coming in here. I'm gonna pop him on there. Hey, Andy, how you doing?
Good.
What's up, Andy?
All right.
You.
Looks like we got a couple of people in chat. Welcome back, Eric. Hi, how are you doing, Jennifer? Thanks for joining us. And
DJ,
we've got
Jen,
the streaming that
awesome.
comes. Hey, CJ's joining us. Awesome. All right. I'm gonna go and bring us up the stream right now. It looks like we're out a couple minutes left.
So,
all right. Well, before we get
one
started,
thing.
yeah, Karl, what do you got?
Noam Brown,
Uh-huh.
OpenAI researcher. To
Yep.
all the AI skeptics out there, this is a good one to tune into. I was like, oh come on. Come on, here we go. Raise that hype. So the
All right,
Dolly
all right.
4 will...
Oh, hi, Justin. Hi, Mario. Thanks for joining us. Okay, so we only got a couple of minutes left before the party gets started. So final predictions. Lock them in. Final answer.
Okay, well, before we do that, who do you think the special guest is?
Oh, right. They mentioned a special guest. Microsoft.
If it's Sadia, I'm turning it off. Like that. No, we know where this is going.
I feel like it's gonna be Santa. Hi, everybody.
Hey, Beth Lyons.
Santa.
Yeah.
Because
Elon
of all
Musk?
the other things.
Elon?
Well, Elon, that would be crazy, right? No, that's not gonna happen. That's not gonna happen.
It would be.
No,
it
he's
would
not
be.
helping OpenAI in any way.
Right.
It would be funny if it was Samta, which I have to give credit to Jen for. So like Sam come all dressed in Santa gear.
There we go. I can see that. Just not and then reveal. Yeah. I think that'd be pretty fun.
Ilya?
Oh, that would be interesting.
That would
Maybe
be
under the water under the bridge and all that,
totally.
and unified face and all that.
Would not be Helen Toner. Helen Toner not be part of this. Not
No.
at all. Not one bit.
But all right. Well, what about our chat?
Mira.
Everyone who's joined us today, yell out what you want to see from day 12.
Who do you think the special guest is?
Oh, special guest. Yeah, yell out
Special
what the special guest is. I totally want to see that.
Jensen? That would be right. Jensen would be right. It was like all hail Jensen. Genuflect to Jensen.
That would be awesome. Yeah, I don't know who else we got. I mean, I think we named all the big players. I'm thinking it'll be a character. I like the Santa idea. I think Santa would be a fun play, wrap up things. But who? But so Sam is Santa. Anyone else as Santa? No.
Elon as Santa.
No, I don't think Elon's coming.
Right.
But it could be Ilya as Santa. I don't think Ilya would do it, but it would be a surprise, right?
Right. Oh, here we are.
We have an exciting one for you today.
Oh, no.
12-day event 12 days ago with the launch of O1, our first reasoning model. It's been amazing to see what people are doing with that and very gratifying to hear how much people like it. We view this as sort of the beginning of the next phase of AI, where you can use these models to do increasingly complex tasks that require a lot of reasoning. And so for the last day of this event, we thought it would be fun to go from one frontier model to our next frontier model. Today, we're going to talk about that next frontier model, which you would think logically maybe should be called O2, but out of respect to our friends at Telefonica, and in the grand tradition of OpenAI being really, truly bad at names, it's going to be called O3. Actually, we're not going to launch. We're going to announce two models today, O3 and O3 Mini. O3 is a very, very smart model. O3 Mini is an incredibly smart model, but really good at performance and cost. So to get the bad news out of the way first, we're not going to publicly launch these today. The good news is we're going to make them available for public safety testing starting today. You can apply, and we'll talk about that later. We've taken safety testing seriously as our models get more and more capable. And at this new level of capability, we want to try adding a new part of our safety testing procedure, which is to allow public access for researchers that want to help us test. We'll talk more at the end about when these models, when we expect to make these models generally available. But we're so excited to show you what they can do, to talk about their performance. Got a little surprise. We'll show you some demos. And without further ado, I'll hand it over to Mark to talk about it.
Cool. Thank you so much, Sam. So my name is Mark. I lead research at OpenAI. And I want to talk a little bit about O3's capabilities. Now, O3 is a really strong model at very hard technical benchmarks. And I want to start with coding benchmarks, if you could bring those up. So on software style benchmarks, we have SweBench verified, which is a benchmark consisting of real-world software tasks. We're seeing that O3 performs at about 71.7% accuracy, which is over 20% better than our O1 models. Now, this really signifies that we're really climbing the
crazy how
as well.
4.0 is not even remotely in that even conversation.
See that O1 achieves an ELO on this contest coding site called Codeforce about 1891. At our most aggressive high test time compute settings, we're able to achieve almost like a 27 ELO here.
So Mark was a competitive programmer, actually still coaches competitive programming. Very, very good. What is your?
I think my best at a comparable site was about 2,500.
That's tough.
Well, I will say, our chief scientist, this is also better than our chief scientist Jakob's score.
I think there's one guy at OpenAI who's still like a 3,000 something.
Yeah,
Gets a few more months to enjoy.
Hopefully we have a couple of months to enjoy there. Great.
That's I mean, this model is incredible at programming.
Yeah, and not just programming, but also mathematics. So we see that on competition math benchmarks, just like competitive programming, we achieve very, very strong scores. So O3 gets about 96.7% accuracy versus an O1 performance of 83.3% on the AMI.
What's your best AMI score?
I did get a perfect score once on this, so I'm safe. But really what this signifies is that O3 often just misses one question whenever we test it on this very hard feeder exam for the USA Mathematical Olympiad. There's another very tough benchmark, which is called GPQA Diamond. And this measures the model's performance on PhD level science questions. Here we get another state-of-the-art number, 87.7%, which is about 10% better than our O1 performance, which was at 78%. Just to put this in perspective, if you take an expert PhD, they typically get about 70% in kind of their field of strength here. So one thing that you might notice, from some of these benchmarks is that we're reaching saturation for a lot of them, or nearing saturation. So the last year has really highlighted the need for really harder benchmarks to accurately assess where our frontier models lie. And I think a couple have emerged as fairly promising over the last months. One in particular I want to call out is EPIC-AI's Frontier Math benchmark. Now, you can see the scores look a lot lower than they did for the previous benchmarks we showed. And this is because this is considered today the toughest mathematical benchmark out there. This is a data set that consists of novel, unpublished, and also very hard to test.
These are extremely hard.
Yeah, very, very hard problems. Even Turnstile houses, it would take professional mathematicians hours or even days to solve one of these problems. And today, all offerings out there have less than 2% accuracy on this benchmark. And we're seeing with O3, in aggressive test time settings, we're able to get over 25%. Yeah.
That's awesome.
In addition to EPIC-AI's Frontier Math benchmark, we have one more surprise for you guys. So I want to talk about the ARC benchmark at this point, but I would love to invite one of our friends, Greg, who is the president of the ARC Foundation, on to talk about this benchmark.
Wonderful. Sam and Mark, thank you very much for having us today.
Of course.
Hello, everybody. My name is Greg Kamrad, and I'm the president of the ARC Prize Foundation. Now, ARC Prize is a nonprofit with the mission of being a North Star towards AGI through and during benchmarks. So our first benchmark, ARC-AGI, was developed in 2019 by Francois Chollet in his paper on the measure of intelligence. However, it has been unbeaten for 5 years. Now, in AI world, it feels like centuries is where it is. So the system that beats ARC-AGI is going to be an important milestone towards general intelligence. But I'm excited to say today that we have a new state-of-the-art score to announce. Before I get into that, though, I want to talk about what ARC-AGI is. So I would love to show you an example here. ARC-AGI is all about having input examples and output examples.
Well, they're good.
They're good? Okay. Input examples and output examples. Now the goal is you want to understand the rule of the transformation and guess it on the output. So, Sam, what do you think is happening in here?
Probably putting a dark blue square in the empty space.
See, yes, that is exactly it. Now, that is really, it's easy for humans to intuitively guess what that is. It's actually surprisingly hard for AI to understand what's going on. So I want to show one more hard example here. Now, Mark, I'm going to put you on the spot. What do you think is going on in this task?
Okay, so you take each of these yellow squares, you count the number of colored kind of squares there, and you create a border of that width.
That is exactly it, and that's much quicker than most people, so congratulations on that. What's interesting, though, is AI has not been able to get this problem thus far, and even though that we verified that a panel of humans could actually do it. Now, the unique part about ARC-AGI is every task requires distinct skills. And what I mean by that is there won't be another task that you need to fill in the corners with blue squares. But we do that on purpose. And the reason why we do that is because we want to test the model's ability to learn new skills on the fly. We don't just want it to repeat what it's already memorized. That's the whole point here. Now, ARC-AGI version 1 took 5 years to go from 0% to 5% with leading frontier models. However, today, I'm very excited to say that O3 has scored a new state-of-the-art score that we have verified. On low compute for O3, it has scored 75.7 on ARC-AGI's semi-private holdout set. Now, this is extremely impressive because this is within the compute requirements that we have for our public leaderboard, and this is the new #1 entry on ARC-AGI Pub. So congratulations to that.
Thank you so much, yeah.
Now, as a capabilities demonstration, when we ask O3 to think longer and we actually ramp up to high compute, O3 was able to score 85.7% on the same hidden holdout set. This is especially important.
87.5.
Sorry, 87.5, yes. This is especially important because human performance is comparable at 85% threshold. So being above this is a major milestone. And we have never tested a system that has done this or any model that has done this beforehand. So this is new territory in the ARC-AGI world. Congratulations with that.
Congratulations for making such a great benchmark.
Yeah. When I look at these scores, I realize
they just got AGI.
I need to switch my worldview a little bit. I need to fix my AI intuitions about what AI can actually do and what it's capable of, especially in this.
They seem to be pretty carefully not saying
the work
that.
also is not over yet, and these are still the early days of AI. So we need more enduring benchmarks like ARC-AGI to help measure and guide progress. And I am excited to accelerate that progress, and I'm excited to partner with OpenAI next year to develop our next frontier benchmark.
Amazing. You know, it's also a benchmark that we've been targeting and been on our mind for a very long time, so excited to work with you in the future.
Worth mentioning that we targeted and we think it's an awesome benchmark. Yeah. We didn't go do specific work with this. This is just the general O3. But yeah, really appreciate the partnership, and this was a fun one to do.
Absolutely, and even though this has done so well, ArcPrize will continue in 2025, and anybody can find out more at arcprize.org.
Great, thank you so much for coming on.
Absolutely.
Yeah. Okay, so next up we're going to talk about O3 Mini. O3 Mini is a thing that we're really, really excited about, and Hongyu, who trained the model, will come out and join us.
Hey.
Hey, Sam.
How are you?
Hey.
Hi, everyone. I'm Hongyu Ren. I'm an OpenAI researcher working on reasoning. So this September, we released O1 Mini, which is an efficient reasoning model in the O1 family that's really capable of math and coding, probably among the best in the world, given the low cost. So now, together with O3, I'm very happy to tell you more about O3 Mini, which is a brand new model in the O3 family that truly defines a new cost-efficient reasoning frontier.
It's incredible.
Yeah, though it's not available to our users today, we are opening access to the model to our safety and security researchers to test the model out. With the release of adaptive thinking time in the API a couple of days ago, for O3 Mini, we'll support 3 different options: low, medium, and high reasoning effort. So the users can freely adjust the thinking time based on their different use cases. So for example, for some, we may want the model to think longer for more complicated problems and think shorter with simpler ones. With that, I'm happy to show the first set of evals of O3 Mini. So on the left-hand side, we show the coding evals. So it's like code versus ELO, which measures how good a programmer is, and the higher is better. So as we can see on the plot, with more thinking time, O3 Mini is able to have like increasing ELO, outperforming O1 Mini. And with like median thinking time, it's able to measure even better than O1.
Yeah, so it's like for an order of magnitude more speed and cost, we can deliver the same code performance on this eval,
or even better experience, right? So although it's like the O3 Mini High is still like a couple 100 points away from Mark, it's not far. It's better than me probably.
But just an incredible sort of cost to performance gain over what we've been able to offer with O1, and we think people will really love this.
Yeah, I hope so. So on the right-hand plot, we show the estimated cost versus code versus ELO trade-off. So it's pretty clear that O3 Mini defines like a new cost-efficient reasoning frontier on coding. So it's achieved like better performance, compared with better performance than O1 with a fraction of cost.
Amazing.
With that being said, I would like to do a live demo.
That sounds great.
On O3 Mini. And hopefully you can test out all the 3 different like low, medium, high thinking time of the model. So let me paste the prompt. So I'm testing out O3 Mini High first. And the task is that I'm asking the model to use Python to implement a code generator and executor. So if I launch this, run this like Python script, it will launch a server locally with a UI that contains a text box. And then we can make coding requests in a text box. It will send the request to call O3 Mini API, and O3 Mini API will solve the task and return a piece of code, and it will then save the code locally on my desktop, and then open a terminal to execute the code automatically. So it's a
very complicated,
pretty complicated task, right? And it outputs like a big chunk of code. So if we copy the code and paste it to our server, and then we would like to launch this server.
So we should get a text box when you're launching it.
Yeah.
Okay, great. Oh yeah,
I hope so.
Yeah.
It seems to be launching something.
Okay.
Oh, great. We have a UI where we can enter some coding prompts. Let's try out a simple one, like print OpenAI and a random number. Submit. So it's sending the request to O3 Mini Medium, so it should be pretty fast, right? So on this
41.
terminal, 41. That's the magic number, right? So it saves the generated code to this like local script on the desktop and then print out OpenAI 41. Is there any other tasks you guys want to test it out?
I wonder if you could get it to get its own GPQA numbers.
That's a great ask, just as what I expected. We practiced a lot yesterday. Yeah. Okay, so now let me copy the code. And send it in the code UI. So in this task, we asked the model to evaluate O3 Mini with the low reasoning effort on this hard GPQA dataset. And the model needs to first download the raw file from this URL, and then it needs to figure out which part is a question, which part is the answer, or which part is the options, right? And then formulate all the questions, and then ask the model to answer it, and then parse the result, and then to grade it.
That's actually blazingly fast.
Yeah, and it's actually really fast because it's calling the O3 Mini with low reasoning effort. Let's see how it goes.
I guess 2 tasks are really hard here.
Yeah, the long tail is often the problem.
Go.
Yeah, GPQA is a hard data set.
Yes.
Yeah, it contains like maybe 196 easy problems and 2 really hard problems.
While we're waiting for this, do you want to show the what the request was again.
Oh, it actually returns the results. It's 61.62%, right? 62%, right?
Cool,
With a low reasoning effort model, it's actually pretty fast. Then full evaluation in a minute.
Somehow very cool to like just ask a model to evaluate itself like
Yeah,
this.
exactly, right? And if we just summarize what we just did, we asked the model to write a script to evaluate itself on this like hard GPQA data set from a UI, right? From this code generator and executor created by the model itself in the first place.
Next year, we're going to bring you on, and you're going to have to ask the model to improve itself.
Yeah, let's definitely ask the model to improve it next time.
Maybe not.
Besides code forces and GPQA, the model is also a pretty good math model. So we show on this plot with like on this AMI 2024 dataset, O3 mini low achieves comparable performance with O1 mini, and O3 mini medium achieves like comparable better performance than O1 if we check the solid bar, which are pass of ones. And we can further push the performance with O3 mini high, right? And on the right-hand side plot, when we measure the latency on this like anonymized O1 preview traffic, we show that O3 mini low drastically reduced the latency of O1 mini, right? Almost like achieving comparable latency with GPT-4o. Where it's under a second, so probably it's like instant response. And O3 mini median is like half the latency of O1. And here's another set of evals that I'm even more excited to show you guys is API features, right? We get a lot of requests from our developer communities to support like function calling, structured outputs, developer messages on O mini series models. And here, O3 mini will support all these features, same as O1. And notably, it achieves like comparable better performance than for O on most of the evals, providing a more cost-effective solution to our developers.
Cool.
And if we actually unveil the true GPQA diamond performance that I ran a couple of days ago, it actually also means that it's actually 62%, right? We basically ask the model to evaluate itself.
Yeah.
Right? Next time, we should totally just ask the model to automatically do the evaluation instead of us doing it. Yeah, so with that, that's it for O3 mini, and I hope our user can have a much better user experience already next year.
Fantastic work.
Yeah, thank you so
really
much.
great work on you.
Thank you.
Cool. So I know you're excited to get this in your own hands, and we're working very hard to post-train this model to do some safety interventions on top of the model, and we're doing a lot of internal safety testing right now. But something new we're doing this time is we're also opening up this model to external safety testing, starting today with O3 mini, and also eventually with O3. So how do you get early access as a safety researcher or a security researcher? You can go to our website, and you can see a form like this one that you see on the screen. And applications for this form are rolling. They'll close on January 10th. And we really invite you to apply. We're excited to see what kind of things that you can explore with this and what kind of jailbreaks and other things you discover. Cool. Great. So one other thing that I'm excited to talk about is a new report that we published, I think yesterday or today, that advances our safety program. And this is a new technique called deliberative alignment. Typically, when we do safety training on top of our models, we're trying to learn this decision boundary of what's safe and what's unsafe, right? And usually it's just through showing examples, pure examples of this is a safe prompt, this is an unsafe prompt. But we can now leverage the reasoning capabilities that we have from our models to find a more accurate safety boundary here. And this technique, called deliberative alignment, allows us to take a safety spec, allows the model to reason over a prompt, and also just tell, is this a safe prompt or not? Oftentimes within the reasoning, it will just uncover that, hey, this user's trying to trick me, or they're expressing this kind of intent that's hidden. So even if you kind of try to cipher your prompts, oftentimes the reasoning will break that. And the primary result you see is in this figure that's shown over here. We have our performance on a rejection benchmark on the x-axis and on over refusals on the y-axis. And here to the right is better. So this is our ability to accurately tell when we should reject something, also our ability to tell when we should refuse something. And typically you think of these two metrics as having some sort of trade-off.
It's really hard to do well on both at the same time.
It is really hard to do, yeah. But it seems with deliberative alignment that we can get these two green points on the top right, whereas the previous models, the red and blue points, signify the performance of our previous models. So we're really starting to leverage safety to get, leverage reasoning to get better safety.
Yeah, I think this is a really great result of safety.
Yeah. Fantastic.
Okay, so to sum this up, O3 Mini and O3, apply please if you'd like for safety testing to help us test these models as an additional step. We plan to launch O3 Mini around the end of January and full O3 shortly after that. But that will, the more people can help us safety test, the more we can make sure we hit that. So please check it out. And thanks for following along with us with this. It's been a lot of fun for us. We hope you've enjoyed it too. Merry Christmas.
Merry Christmas. Merry Christmas.
I didn't realize they had an internal audience at OpenAI to, be submitting their applause on that one. So I just want to comment on, OpenAI is drilling forward toward AGI.
Yep.
And at the same time, they seem to be better than many of the other frontier model developers at creating usability for the general public, which is a totally different mission, right? And what we got a glimpse into by meeting the head of research, who astoundingly is able to score 100% on some amazing math Olympiad thing. Okay, so this guy's got a major brain going on in there. So these are the people who are proceeding toward the evaporation of any decay in the advancements of models. There's been a lot of talk several months ago about, hey, we're reaching the limits, the saturation of our ability to increase the capabilities of AIs in respect of reasoning and all these other things because of limitations on the compute that's available and the training data that's available. Now, and there are lots of, sensible observers who have said, there are many, many different, alternative methods to approximate AGI and go beyond that to ASI and more generalized ASI. And we get a glimpse into that here. Really, really impressive increases in the ability of this new model O3 to perform on the major benchmarks, including the ARC models. That we had a show about, or we mentioned and discussed ARC, the ARC prize and the ARC approach many, many months ago. And this is the first time it's resurfaced in this conversation, but it is really the ultimate test of whether we're approximating AGI.
And just to kind of level set for those who aren't in tech or code or anything like that, humans typically score on that level 85 to 100. So for a model to score at 85 is ridiculous. Just pure ridiculous if you actually think about, like, when my presentations, I go AGI 2 years, 7 years, whatever that is. I'm not sure if the gravity of this is 85. You are at human, you literally human level. So O1 Mini, O3 Mini, O3 itself, and whatever model comes after O3 is literally AGI. I don't know how that is a pretty ridiculous thing to have. So when Sam is talking about, the mission of artificial general intelligence at the level of human intelligence, one could arguably say O1 is there at the bottom level. I could just imagine what that is. Yeah, that is ridiculous what we're going into 2025 with.
So I agree with you. And when we talk about OpenAI and AGI, we also need to bring into the conversation that their statement that they've reached AGI has consequences in terms of the business model of the nonprofit. And they are currently undergoing a situation where they're trying to change the business model. So it's not a nonprofit, it's a for-profit. It also has consequences for Microsoft. And I saw some of the chat about like Microsoft said, no, you can't call it AGI because of course, when the consequence for Microsoft is that they don't get it.
Yes.
Right.
They do not get this. Yeah. Like,
but
I just wanted to share that benchmark on ARC-AGI again and to show like what we're playing with and what we will play with coming February in less than a month and a half, 2, it doesn't matter. 2, who cares? We're getting
they definitely took the extra little bit of time saying, okay, I know you all want it now, but we need to do some safety rounds. And I do like that they added the where you could submit your own testing for guardrails and red teaming and things like that. I think that'll be definitely helpful. But yeah, I'm excited to see what it what's going to come out of this.
I think I just want to answer Gareth's question there about like, do you think we can really evaluate AGI until AI can take fully control? I think like AGI in terms of like at human level intelligence, I don't know if that's the same as taking an action as a human. So I don't know if that, I feel that those are two different things, being at the level of intelligence versus taking the action of a human. I feel like those are two separate things we're talking
about. The distinction in my mind is that it's the decision on which action to take that's the representation of intelligence. And so they're differentiated in some way.
Yeah. But just like any human, right? Like to have that 85 to 100, to have it at 88, and then imagine us tuning that O3 model to a very specific set of actions or very specific set of tasks, that number will increase. So you are literally on this scale, you have something that is better than a human, lots of humans, period. Like that.
The O3 mini examples that were shown really represent the kind of agentic capabilities that are becoming out of these new models because of the reasoning capabilities.
Yes.
It was given a specific prompt, and yet it had to figure out how to solve that specific prompt and take specific sequential actions in order to get to the result. And then it did that without any further instruction or without any inquiry back to the prompt.
Well, what it didn't say, but it gave the pieces, right? So the pieces of the puzzle were demonstrated, but not discussed in this way.
Yeah.
But what they showed us was the chief of staff, right, who would reason what's the next piece that is needed. And they showed us the ability to spin up a program with an intention that would also evaluate. He added evaluate itself, but that same process could potentially evaluate the level that the task was completed to.
Yes.
Right? I mean, they didn't say this is like your mixture of agentic experts, but they sure showed that that those characters could come to play within this system.
So if it can evaluate its own score, like, oh, I only completed 61, 71%, then the reasoning would be if complete only at, only execute at, let's say 80%, then literally it could self reasons like, okay, not complete, not complete, not complete. Right. And even though that looks like right now, oh, that's just a bunch of coding. It's like, no. If you apply that to, simple example, hey, build me a newsletter that does this. If you set a benchmark of like, it is only complete if these tasks are, it can do these things in this criteria, it will keep doing it until it hits that criteria. Regardless, like the score doesn't matter. Like it does, but it doesn't. But because when you program it that way, so literally it is learning and keep reasoning itself until it builds that model. Take outside of coding and math, put it into real world situations. Now you're like, whoa, it is literally most of the quote unquote agents right now is all about trigger, action, trigger, and all these different steps. But now it's like, oh, this doesn't work. I'm going to keep doing this. I'm going to keep doing this. I'm going to keep doing this until it executes the entire thing, not by a trigger, but what the goal is set, which is amazing.
And that's why deliberative alignment is really important, because what you just described is the paperclip problem.
Yes.
Right? Which, and if I assume everybody watching us knows the paperclip problem, but in case you don't, the goal is we need to make paperclips. That's the whole reason for existing. Paperclips are made out of iron. And at some point, there's no more iron left, except humans have iron in them. And so now the iron in humans is being used to make paperclips. So you need a deliberative, no.
Yeah.
there's a point before that no, that we don't want to use the iron in humans.
So Gwen's question about, so are agents needed? Well, I think the ability of this thing to reason itself out enables the building out of really a lot of different new things. Like I would say with something like this, briefly what we saw is like, well, there's a whole new set of operations that you can create, right? Like I just go back to Zapier, make, respell, relevance. Like, well, you could task it to actually go through that, or you could task it to complete the actual task itself. And I'd love to essentially testing the model against the current workflows and go, can this model now compete directly with any of those workflows that very complex workflow that you built? According to 88%, that level, I would say yes. Or
so long as the model has function calling and access to tools and access to the web, and all of those things are being added as we speak to almost every major frontier model provider. So yes, I think what we're seeing is not the need to define specific agents, but the frontier models, albeit more expensive than a bespoke agentic workflow development in terms of their operating costs, they're going to be all in one packages.
Yeah.
Mm-hmm.
Yeah.
I have to say that there's a comment from Charles Darwin in our chat saying,
wow.
It's over humans. And ooh, is this survival of the fittest kind of get to replicate? Thank you, Charles.
Thanks for returning from the past. That's a quantum thing.
Yeah.
Okay, one of the other things I wanted to mention is that, when Karl, you were showing the chart of what the ARC Prize accomplishment of O3 is, and you mentioned that, this is what we're working with right now down here in the O1 range. And now that's where O3 is. I want to just acknowledge that I don't work anywhere near what the capabilities of O1 are at this point.
Yes.
I mean, so, that O3 capability is out there in the stratosphere of mathematical and, physics and other kinds of problems that of course we want AGI to address. But in terms of practical applications at the business level or in my own mind, O1 is perfectly sufficient. I don't even know how I would evaluate what the difference was with test time compute high O3. What could I possibly apply that to in my meager application range?
Yeah.
Well, and in your head of research example, right? He would not be displaying human general intelligence. He would be displaying human super intelligence to score the 100 on the test, right? So there's...
Yeah.
Also, there was Jyunmi, there was a part of this that was super exciting, and also are we watching what people who build these models find exciting?
I think
it felt very much like, look at this graph. This is amazing.
Yes.
And it's like, wow, it's many colors of blue, and I'm very excited for how excited you are, right? But there was an aspect of, I now need you to explain to me
what it actually means.
Absolutely. Yeah. And I think that's what we'll be seeing over the next couple of months, is a deeper analysis of all of each of the things they announced. It did feel like another little dev day, because it's like, we built this thing. We haven't been able to do this before. And look how easy it is to do this thing now. It's like, okay, that seems like a very specific use case. Now apply it to my own life. And then you'll see everybody explode in excitement and things like that, right? So I think over the next couple of months, before we can get our hands on it, we'll see more and more crumbs of awareness. I think somebody had mentioned that in chat. And it'll be really great to get our hands on it. And I want to see comparisons. Like you said, Andy, it'd be really hard to compare between what the output of 01 is and the output of 03. But I'd like to see what those use cases are. I'd like to see the problems being solved, and how it can be applied.
It also opens up the question again of whether the Gemini 2.0 with thinking, which was announced just yesterday, how that compares on these same benchmarks, because they did have one display where they included Gemini 1.5. Okay. And I think they should have, that was like a slap to Google to, put them at the left-hand side of the chart with 1.5. Well, I'm sorry, 2.0 has come out, and it's way dramatically better than 1.5. So that's an antiquated chart. So I'm curious now to see whether, it's going to be Meta and Google and Grok, the X AI. All of these are going to be able to not necessarily keep pace with the advancements that OpenAI is achieving, but they're going to match them pretty quick as fast followers. There's not going to be a long delay between what you just saw presented in performance on the benchmarks as delivered by OpenAI research and what Google DeepMind already has running in the background. So they're just not presenting it. And Google has this immense advantage of being able to incorporate these capabilities directly into your current workspaces. OpenAI is not a current workspace except for the cognoscenti who are following AI and have their subscriptions and are working on the API and so on. But Google, everybody's in Google every day, pretty much. Not everybody. I mean, there are some holdouts like Jyunmi who's still working on Opera or something. Chrome and Google Apps and Gmail are all going to have these very advanced capabilities very quickly.
Yeah.
Google also has the deep pockets that you can use Google's premium models for free right now. So so go to aistudio.google.com if you want to play.
It's aistudio.google.com. Yeah. Yes.
Did I say that?
All right. Well, I think that's going to wrap it up for us, unless you have anything else that you really got to mention right now.
I got one more thing for early access to safety testing.
Yeah.
You can't just go in there and be like, hey, I want to test it. Like they actually ask for past research papers. You have a GitHub repos to demonstrate your work. Like, you actually have to.
So it's like, we opened it to the public, but we really didn't open it to the public.
For people who are actually researchers and who have done research, and you can prove it. So
so everybody be prepared for February. Yeah, that's when we'll really get a chance at it.
We don't know who's still in the audience. So if you apply and you get in,
that'd be awesome.
Come back and let us know.
That's true.
You can reach us at thedailyAIshow.com. You can come to our live streams. We are thedailyAIshow@gmail.com. Also, we want to know what your experience is if you have research papers and Gits to share with them and get in. Yay.
And if the 12 days of OpenAI has been your introduction to the Daily AI Show, just remember Monday through Friday, 10 a.m. Eastern, we do a live stream as well. And if you want to find out more, keep in touch. go to thedailyAIshow.com and sign up for the newsletter. All right, everybody, this 12 days of OpenAI has been overall fairly exciting. And the days that weren't so exciting, we had fun with them anyways, because everybody likes to complain about something. So hopefully we'll see you all come Monday. If not, we'll hopefully your holidays have done well. All right. Bye, everybody. Aloha.